Hi everyone. So today I'm going to be doing lesson 3.6, Solving Inequalities. This lesson is going to be building up on lessons 3.1 to 3.5 because you're going to learn how to solve inequalities similar to the way you've solved equations. So I want you to do the warm-up by yourself. So it says to fill in the following chart, and the first two lines have been done for you as examples. So I want you to pause the video and come back when you're ready to check your answers. Okay, so I hope you've done the chart, and I'm going to take up the chart with you. So the first line, the sentence says, x is greater than 3. And the second line, it says that y is less than or equal to negative 1. So I want you to pay close attention to the fact that in the first line, it says that x is greater than, and in the second line, it says that y is less than. So the part where it says is less than is different from lesson 3.4, where you would often see that, for example, 7 less than a number. So when you see it say 7, for example, like 7 less than, it means that you're taking 7 away from a number. But if you recall where you see the word is, that normally means equals. So in this case, if you see that it says is less than or is greater than, it's referring to an inequality. So the first one for us to try, the inequality has a W and then a less than sign and then 5. So that means that the sentence should be that W is less than 5. So in this case, when we choose true and false values, they may differ for every person, but a true value is one that satisfies the inequality. So in this case, a number that is less than 5, and a false value would be a number that does not satisfy the inequality. So in this case, it would be a number that is greater than 5. So in this case, a true value could be 4, and a false value could be 6. So let's look at the next one. So the inequality is given to us, and as a sentence that would say that A is greater or equal to 0. So it's greater or equal because you have the greater than sign, because A is greater, but the line underneath is an equal sign. So that means part of an equal sign. So that means that A is greater or equal to 0. So in this case, a true value could be 0 because remember that it says that A could be equal to 0. Or a number or a false value could be, for example, negative 3 because that is a number that is less than 0 and that does not satisfy the inequality. So for the line after that, it says x is greater than or equal to 7. So similar to the one above, it also says greater than or equal. So your inequality would be x is greater or equal to 7. And then a true value could be 9 because that satisfies the inequality, and a false value could be 5 because it doesn't satisfy the inequality. So then the next line says that b is less than negative 10. So your inequality would be b, then the less than sign, and negative 10. So then a true value could be negative 11 because that is less than negative 10, and a false value could be negative 7 because that is greater than negative 10. Now for these next two lines, the answers may vary. As long as your true and false values satisfy and don't satisfy the equation respectively, then your answers will be correct. So an example for the first one, or the second from the bottom, it could be that x is greater than 7. Because the true value 8 is greater than 7, but 6 is smaller than 7, so it doesn't satisfy the inequality. So for the last one at the bottom, we want an inequality that satisfies the true value of -4, but -1 would not satisfy the inequality. So an example of this could be that y is less than or equal to -2.
That's it for the warm-up questions. If you got any of them wrong, I just want to remind you that the true value should satisfy the inequality, while the false value should not satisfy the inequality.
So moving on to the next section, solving equations versus solving inequalities. So the next steps for solving equations and inequalities are the same for the following operations. So I want you to try to solve these equations and inequalities below, knowing that they should be the same. Okay, so I hope you pause the video and tried it by yourself. So let's look at the first addition and subtraction equation and inequality. So for the equation, you should have x equals 5 plus 3, which means that x equals 8. Now remember that the steps for solving equations and inequalities should be the same. So when you solve the inequality, you should do the exact same steps when it comes to addition and subtraction. So x is greater than 5 plus 3, which means that x is greater than 8. Okay, so let's move on to the multiplying and dividing with positive numbers. So it's important to highlight that this is only the same, like the steps are the same when you're dealing with positive numbers in multiplying and dividing. So we have that 7x equals 28, which means that x equals 28 over 7, so x equals 4. When we look at the inequality, the steps should be the same, so that means that x is less than or equal to 28 divided by 7, which means that x is less than or equal to 4. So remember that the steps for solving equations and inequalities are the same when it comes to adding and subtracting and multiplying and dividing with positive numbers. However, inequalities are different from solving equations when dealing with different from solving equations when dealing with multiplication and division of negative numbers. So in this case, the inequality operator is going to be reversed. So for example, if you start with a greater than sign and you multiply or divide by a negative number, it will become a less than sign. So let's look at this example on the right here. We have that 5 is greater than 3, which is true. So now when we multiply both sides by -2, so -2 times 5, and we have -2 times 3, something changes. So if we look at the last step here, we have a -10 and a -6. So we know that when we multiply with a negative number, the inequality operator should be reversed. So instead of greater than, it should become a less than sign. And when we look at the end again, -10 is less than -6, so the inequality is true. If we hadn't reversed it, then the inequality would be false. So it's important to remember that when you multiply or divide by a negative number, you must switch the inequality operator in order to keep it true. So try the next two examples by yourself with multiplication with a negative number and division with a negative number. Just pause the video and come back to it when you're done. Okay, so I hope you tried those examples by yourself. So I'm going to go over them to make sure that you did it correctly. So with an equation, you just solve it with the steps you've already known from the past 5 lessons. So x equals negative 20 divided by negative 4. So x equals negative 5. However, with the inequality, we have, when we're dividing by a negative number, you have to remember to switch the inequality operator. So instead of saying that negative 4x is greater or equal to 20, we have to say that x is less than or equal to 20 divided by negative 4. So this less than or equal to is a reverse inequality. So we have that x is less than or equal to negative 5. So it's very important to remember that you have to reverse the inequality operator. So let's do the same thing, but with division with a negative number. So when we solve this equation, we have that x equals negative 3 times negative 6. So x equals 18. Now with the inequality, we have that negative x over 6 is less than negative 3. But since we are dealing with a negative number, we have to switch the inequality operator to become a greater than sign. So it becomes x is greater than negative 3 times negative 6, which means that x is greater than 18. So let's try the example on the back. So example number 1 says solve each inequality and then test a true and a false value in your left side, right side check. So when you test a true value, you want to prove that your inequality is correct. So for example, in example 1a, it says negative 3x plus 8 is greater than negative 7. So when you solve the inequality, you want to choose a true value that satisfies it. And if you get that, for example, a, that your left side is greater than your right side, it's true, which means you solve for it correctly, but you also have to test your false value. So when you test a false value, you're testing a value that does not satisfy the inequality, and you want to prove that your false value doesn't satisfy the inequality. If it does satisfy the inequality, then you've likely done something wrong when solving it, and you want to go back and check your answers. So let's try example 1a. I want you to try solving it by yourself, and then come back when you tested your true and false value. Okay, so I hope you solved example 1a. So let's just go through it right now. So we have that negative 3x plus 8 is greater than negative 7. So you can rewrite this as negative 3x is greater than negative 7 minus 8. And then that means that negative 3x is greater than 15. Sorry, negative 15. And then you can divide both sides by negative 3. Which means that x, and don't forget, because you're dividing by a negative number, you have to switch the inequality operator. So that means that x is less than 5. So you could have taken any value that satisfied the inequality for the true value. So I'm just going to test x equals 4. So let's take the left side of the inequality, which states that negative 3x plus 8 is the left side, and on the right side we have negative 7. So I'm just going to plug in 4 for x. And then you should get negative 12 plus 8, which equals negative 4. So you notice that it's true that the left side is greater than the right side, which is what the original inequality stated. So don't forget to write therefore left side is greater than right side, and that this is true. So now let's try the false value. So I'm going to choose x equals 6 because that does not satisfy the inequality. And then if we write in our left side and right side again, 3x plus 8 on the left and negative 7 on the right. Just going to plug in 6 for x. And that equals negative 18 plus 8, which equals negative 10. So we prove that this false value does not satisfy the inequality, which means that the answer we found when solving the inequality is correct. So I want you to try example 1b by yourself and choose a true and false value to test as well. Okay, so I hope you did example 1b by yourself, so I'm just going to go over that. So we have that 10 minus y over 4 is less than or equal to 2. So we have that negative y over 4 is less than or equal to 2 minus 10, which means that negative y over 4 is less than or equal to negative 8. So now we have to multiply both sides by negative 4, which means we have to switch the inequality operator. So we have to reverse it. So it says that y is greater than negative 8 times negative 4. So I'm going to write this underneath, but that means that y is greater than or equal to 32. So on our left side, we have that 10 minus y over 4, and our right side is 2. So I'm going to choose x equals 40 for my true value. Could have chosen anything else as long as it satisfies your inequality. And let's plug that in. So 10 minus 40 over 4 equals 10 minus 10, which equals 0. So as our original inequality states, our left side is less than our right side. So this is true. Now let's try our false value. So I'm just going to recopy the left side, which is 10 minus y over 4, and our right side, which is 2. So in this case, I'm going to choose a number that is less than 32. So let's say x equals 28. So 10 minus 28 over 4, which equals 10 minus 7, which equals 3. So we showed that our left side this time is greater than our right side, which is false for our original inequality. Oh, sorry. Okay, so when I was testing the true value, I'm going to change the x to y because that's the variable that was used in this inequality. But the steps are the same. So you just plug in those values for y like I did, and then you want to prove that your original inequality was true. So I want you to try example 2 by yourself now that you've had some practice solving inequalities. These are multi-step ways to solve, similar to the ways that you've learned from 3.1 to 3.5. So just pause the video and come back to it when you want to check your answer. Okay, so let's look at 2a. So 2a says that 5x minus 11 is greater than or equal to 7x minus 13. So like solving multi-step equations, you want all your variables on the left side and all your constants on the right side. So let's do that right now. So we already have 5x on the left side, so we don't have to do anything to it. And now we're moving positive 7x to the left side, so it should be minus 7x. It's greater or equal to, we can keep the negative 13, but now we're moving negative 11 to the right side, so that's going to be positive 11. So you should get negative 2x is greater than or equal to negative 2. Remember that when you divide by a negative number, you have to reverse the inequality operator. So now it's going to become a less than or equal to sign. You should get that x is less than or equal to 1. Okay, now let's look at 2b. Okay, so the first thing I notice is that you have to do several distributive property first before you can start rearranging. So the left side here is 7x minus 14 is less than 9 plus 8x plus 4. So we can simplify the right side a bit more before we start moving variables and constants. So we have 7x minus 14 is less than 8x plus 13. So again, let's move all the variables to the left side and all the constants to the right side. So we have 7x minus 8x is less than 13 plus 14. So that should be negative x is less than 27. So remember, we need a positive variable, so we have to divide both sides by negative 1. So you should get that x, and remember when dividing by a negative number, you have to reverse the inequality operator, is negative 27. So x is greater than negative 27. So now for the final example, in example 2, this is just like your fractions equations. So we have to find the lowest common denominator first and multiply every term by it. So the lowest common denominator of 3 and 7 is 21. So I'm just going to write that up here. You do not have to, but it's just so you know what the lowest common denominator is. So let's do 21 times x plus 8 all over 3 is greater than 21 times x over 7 minus 4 times 21. So just remember that with the fractions, you're dividing the lowest common denominator by the denominator of your fraction. So 21 divided by 3 gave us the 7 here. 21 divided by 7 gave us the 3. So now we can expand this with distributive property. So we can get 7x plus 56 is greater than 3x minus 84. And moving all the variables to the left, we get 7x minus 3x is greater than negative 84 minus 56, because we're moving the 56 on the left to the right side. So we get that 4x is greater than negative 140. So we're dividing both sides by 4 now, which means that we get that x is greater than negative 35. So I hope you've had some good practice solving inequalities now with these examples, and we're going to move on to some application questions. So let's look at example 3. Keith has $800 in his savings account, and he withdraws $50 each week for food. To avoid paying fees in the bank, he needs to maintain a minimum balance of $200 in the account. Write and solve the inequality that represents how many weeks Keith can withdraw money from his account without paying a fee. So the question is asking us how many weeks Keith can continue to withdraw money. So let's make a let statement saying that W should represent the number of weeks that he can withdraw money from his account without paying a fee. So I want you to try to solve this inequality by yourself. So just pause the video, try to set up the inequality and solve it, then unpause it when you want to check your answer. So it says that Keith has $800 in a savings account and he withdraws $50 each week for food, but he needs to maintain a minimum balance of $200 in the account. So that means that he can have $200 in the account, but he can't go under $200. So we should set up the inequality to say that he has $800, but continues to take out 50 each week. So that is 50 times W, because W, we said, would represent the amount of weeks he can continue to withdraw money. And all of this has to be greater or equal to $200, which is the minimum balance he's allowed to have. Okay, so let's solve this inequality. So we have that negative 50W is greater or equal to 200 minus 800, which means that negative 50W is greater than or equal to negative 600. So when we divide both sides by negative 50, we should get that W is less than or equal to, because remember we're dividing by a negative number, so you must reverse the inequality operator, 12. So don't forget to write a concluding or therefore statement that answers the question. So the question is asking us how many weeks can Keith withdraw money from his account without paying a fee. So on the side here, I'm going to write therefore Keith can withdraw money for up to 12 weeks. And that's all you need for this first question. So now that you know how to create your own let statement and own inequality, I want you to try example 4 by yourself. So just pause the video and come back to it when you want to take up your answer. Okay, So example 4 says that Onara has been offered a new job that pays $48,000 a year plus 3% of sales. For what total sales would this new job pay more than her current job, which pays $60,000 a year? Write and solve the inequality that represents this scenario. So we can say let X represent the amount of sales. So let's try to set up this inequality. So we know that her current job pays $48,000 a year. And she also makes 3% of sales on top of that. So just convert 3% to a decimal. So that should be 0.03x. Because the question is asking us what total sales would this new job pay more than her current job? And she currently makes 3% of sales. So 0.03x is how you would represent how much sales she currently makes. And her current job pays $60,000 a year, and we want to know when she would make more money than her current job. So this new job, which is the 48,000 plus 0.03x, should be greater than the amount she's making at her current job, which is 60,000. So from now we can just solve the inequality. So we can write 0.03x is greater than 60,000 minus 48,000, which means that 0.03x is greater than 12,000. Just divide both sides by 0.03, which means that we should have that x is greater than 400,000. So that means that Onara would have to sell more than 400,000, or she would have to have 400,000 current sales. So I'm going to write that on the side. Onara would have to sell more than 400,000. And that's all you need for example 4. So that's the end of lesson 3.6 for creating and solving inequalities.